Another way of categorizing the variables used in statistics is called levels of measurement. These categories will be useful as we get further into the class by making it clear what things we can do with the data that we collect. Now, the two highest level categories, nominal and ordinal, are similar to the qualitative and quantitative variables that we discussed in the last presentation. Nominal data are made up of things like names, labels, and categories. They're non-numeric values like colors and yes or no responses. Now, the second level, ordinal data, are made up of values that can be arranged in some kind of order, but where the differences between the values don't have any meaning. So to see what that means, let's look at some specific values. Now, text responses like true or false are always going to fall in the nominal category. When we talk about educational experience, we mean things like middle school, high school, undergraduate college, graduate college. These are values that can be sorted or ranked. For example, a high school diploma is higher than a middle school diploma, but lower than a college degree. However, there's no way to define the difference between a high school diploma and an undergraduate degree, or an undergraduate degree and a graduate degree. That's what the definition of ordinal means when it refers to difference not having any meaning. So educational experience would go into the ordinal category. Now, salesperson rankings are similar to educational experience. The rankings can be sorted so you know who the top salesman is, who the second best performing salesman is, etc. However, the rankings don't give us any information about the difference between first place and second place. For example, the difference may have been $100 in sales or $10,000 in sales. We don't know. So this variable would go in the ordinal category. Now, Social Security numbers are a little tricky. They're numeric, so they can be sorted, which might have you leaning toward the ordinal category. But to qualify as ordinal, the ranking has to have some meaning. With the sales rankings being first versus second tells you something about the two people in each position. With Social Security numbers, knowing that number 111-00-0000 comes before 111-00-0001 doesn't give us any information about the people assigned those numbers. Because the ranking doesn't tell us anything about the results, Social Security numbers are nominal data, not ordinal data. Variables whose values can be sorted can be broken down further into interval data and ratio data. Now, like ordinal data, both of these types can be sorted, but with interval and ratio data, the differences between individual values have some meaning. Now, what distinguishes interval and ratio data is the existence of a natural zero. So to see what this means, think about the sales figures for a company. Sales figures can be sorted, and the difference between two sales values, for example, $1,000 versus $1,800, tells us something about the difference. It also makes sense to talk about having $0 in sales. Sales figures have a minimum possible value, and it's possible for a store to actually have that value. That's what we mean by a natural zero. And because sales figures have that quality, they would fall into the ratio category. So let's look at some more examples and see how they fit into these two new categories. The number of insects per square foot is something that can be ranked, it makes sense to talk about, for example, 100 being greater than 90. And the difference between two numbers also has meaning. Comparing to 100 to 90 tells me that there are exactly 10 more insects in one sample than the other. Also, there can't be fewer than 0 insects per square foot. And it's possible for a piece of land to actually have that value. So the variable has a natural 0 value. Put together, all of those qualities put this variable into the ratio category. Now, patient temperatures can also be sorted, and taking the difference of two temperatures tells us something about the two patients. So this variable is definitely not just ordinal. Now, it's hard to talk about a 0 value. It's safe to say that there's a minimum value a patient could have. For example, a patient could never have a temperature of 0 degrees. But there's no way to define what that minimum temperature is. For example, a temperature that would be deadly for one patient might not be for another. So because we can't clearly define a minimum value that's going to apply to every patient, patient temperatures would have to be interval data. Now, thinking about blood alcohol levels, these numbers can also be sorted, and their differences are meaningful. And it's also possible for a person to have a 0 blood alcohol level, and you can't have a level any lower than that. So this data has a natural 0, which puts it into the ratio category. Now, I put Social Security numbers on here again so we could look at those values related to our two new criteria. So you can sort Social Security numbers, but because the order doesn't tell you anything about the people who have the numbers, we can't talk about a minimum Social Security number. So the data doesn't have a natural 0 value. And also, if you subtract two Social Security numbers, you don't get any useful information about the people who have the numbers. So this data wouldn't qualify as either as either ratio or interval data. On this slide, I listed our 4 new data types in the rows and their qualities in the columns, so you can get an idea of how they relate to each other. This lets you see how each category is the same as the previous one, but with a new requirement added. For example, ordinal data is nominal data with the added requirement that the data can be sorted. Interval data is the same as ordinal data with the additional requirement that differences between the values have meaning. And ratio data is interval data with the additional property of having a natural 0 value. So I've listed our 4 new values here in terms of their hierarchy so we can talk about what you can do statistically with each one. Now, with nominal data, you're going to be limited to operations that involve counting, such as reporting the frequency of each value or how many people gave each response to a question. Now, we can also give statistical values that involve counting, like the mode of the data. And we'll talk more about things like the mode when we talk about descriptive statistics. Now, with ordinal data, we can do a little more because the data can be sorted. We can do things like producing rankings of the results. And with interval and ratio data, we can do things like calculate percentiles and averages. Now, it's at this point that we really get to open up our statistical toolbox and take out a wide range of statistical techniques that will let us draw a lot of different conclusions about the data. So in our next video, we're going to start our last topic in the data collection process. We'll look at the different methods that statisticians have for actually going into the field and collecting these large data sets.